This is the way the new system would work.
Hey fellas, welcome back to another video. Today I'm going to be making a compound called Perthiocyanic acid. A while back you may remember I made a video on Perthiocyanogen, and while that was pretty cool, there weren't a ton of things you could do with the end product. So starting first, let's look at the setup. I have a 1 liter 2-necked round bottom flask with the outer neck connected to a, I believe it's a 125 milliliter pressure equalized addition funnel, and the top neck of the flask is occupied by a gas takeoff adapter with a hose going to a sodium hydroxide solution in a wash bottle. So first we're going to prepare a solution of sulfuric acid. First of all, I'm going to add about 50 milliliters of distilled water to this conical flask on a stir plate. Turning the stirring up, I am now going to add about 65 milliliters of concentrated between 93 and 98% sulfuric acid. 65 milliliters may be a little low. I have found you may need a bit more for this reaction to work the best. But anyways, I'm just going to add about 65 milliliters here, and I can add more if I need to down the road. As usual, add the acid to the water, not the other way around, because there is a chance it can get hot enough to boil and splash some acid solution around. That's not very fun. Also remember to add it slowly so that the solution doesn't get too hot too quick. After the solution is stirred thoroughly, I went ahead and went outside back when there was still snow and collected about 10 kilograms of fresh New England snow. Other types will not work. The solution was then cooled down to about freezer temperature. While the acid solution is cooling down, the next step is to make a solution of potassium thiocyanate. First I started by measuring out 60 milliliters of distilled water, which will then go into a 250 milliliter beaker. Next, I weighed out about 100 grams of, oh my god. I mean, 100 grams of potassium thiocyanate, despite what the bottle may say. It's cyanate, not cynate. What the f... Once that's all dissolved, the thiocyanate solution is added to the flask. If you're more of a visual learner, our resident artist has provided a illustration to show you exactly what I mean. Once that's all added, I went ahead and added a bunch more snow to cool this solution down. There's no exact temperature that you need to reach, just needs to be pretty cold. After double checking that the stopcock is closed, I went ahead and added the sulfuric acid solution, which is now sufficiently cool, to the addition funnel. Once ready, the stopcock is opened very slowly and the acid solution is allowed to drip in. This creates a red color, which I believe is some sort of intermediate product, and is not the final perthiocyanic acid. If you look closely enough, you'll see that where the two solutions meet, there's a solid forming, and that's just potassium sulfate mixed with the unknown red product. Eventually, as more and more of this stuff forms, it will start to become a problem and will interfere with stirring, so try to keep an eye on that. So now let's discuss what exactly is going on here in this reaction. There are a couple of reactions going on, but the first and foremost is the reaction of the sulfuric acid with the potassium thiocyanate. A small portion of this does get vaporized, but the majority undergoes decomposition and forms perthiocyanic acid and hydrogen cyanide. Now before you start to think anything, let me ease your fears. The hydrogen cyanide formed is almost immediately hydrolyzed into ammonia at formic acid. There are some other gases that are evolved, which include carbon dioxide, and in small quantities, carbon monoxide, and carbonyl sulfide. However, these gases do not form in large quantities immediately, and only form in small quantities themselves later in the reaction. Any potential dangers of these gases are easily mitigated by a sodium hydroxide gas trap. After a long enough time, the reaction may need to be stirred manually due to the formation of large quantities of potassium sulfate. This may require unconventional methods of stirring. The mixture in the flask was left to sit for 2 days connected to the gas tube. And now the mixture is just left to sit for about 2 days in my case. I don't know if it's any more successful if you leave it for longer, but 2 days ended up working just fine for me. After a couple days have passed, the mixture has darkened to a sort of golden color. Now that it's reached this color, it's time to filter. This shouldn't take too long. However, do mind that it may smell a little bit. So now we can see the dry product along with a byproduct of crystallized, most likely potassium sulfate. You can see on the top there. That's no big deal because we're going to remove that in the next step, which is quite arduous, and that is recrystallization of the acid from boiling water. So this task is extremely time-consuming and resource-intensive because the acid is not very soluble in water, even when it's boiling. It is slightly, but it's not great. However, I didn't want to use a ton of solvent to recrystallize it. Now that I think about it, I don't even know what kind of solvent to use. So I ended up using somewhere in the range of about 20 liters of water. This is only like 1 out of 5 steps that you're seeing right here. And I still have a bunch left over, so it's absolutely not the most efficient way, but it's really the only way that I know of that wouldn't require using a ton of solvent. The recrystallized acid looks very nice and should be good for further tests. The literature mentions that a potassium permanganate solution, when heated with the acid, should be reduced to manganese dioxide, sulfuric acid, and carbon dioxide, as well as nitrogen. So what I did is added a small amount of the acid to a rather weak permanganate solution, and then heated it on the hot plate. If you look closely enough in the next part, you will be able to see the bubbles of gas and the formation of manganese dioxide, which will be quite apparent. Another interesting property of the pure acid is its ability to dissolve in some amines. In this case, I'm using anhydrous ethylene diamine to dissolve the acid, which will give a nice dark green solution. When this mixture is diluted with water, a golden solution is obtained. The salt of a supposed dithiocyanate acid is obtained when a hydroxide, in this case potassium hydroxide, is mixed with ice to create an ice-cold hydroxide solution. This is then combined with the solid acid to form sulfur and a yellow solution of the supposed dithiocyanate salt. The solution of the potassium salt mixed with the sulfur is then put through a centrifuge to separate the very finely powdered sulfur. This will leave a yellow solution of our desired salt. First up, I'm going to attempt to make the copper salt, copper dithiocyanate. I first start out by putting a small amount of copper 2 chloride dihydrate in a beaker and adding enough water to dissolve it. The cold solution of the potassium dithiocyanate is then added to the copper 2 solution. This forms an olive green precipitate, which honestly was not what I was expecting. However, I soon realized that the solution of the dithiocyanate that I made was probably going to be pretty darn basic, and any salt that I got, after adding this basic dithiocyanate solution, would probably be a sort of basic salt. So what I did next is added a weak solution of acetic acid to the dithiocyanate precipitate in the beaker, which then formed a presumably neutral salt that had a nice brick red color. I continued to add the diluted acetic acid until the pH paper that I was dipping in read neutral. I then attempted to make the lead salt starting from lead 2 nitrate. Again, I added the dithiocyanate solution and understandably co-precipitated what I believe to be some sort of hydrated lead oxide along with the lead dithiocyanate. It is important in this case to acidify with acetic acid or nitric acid to make sure that the salt does not precipitate out like it would with hydrochloric acid, forming insoluble lead 2 chloride. Next up is the cobalt salt, starting from cobalt 2 sulfate. Again, the same procedure applies here. After cobalt comes nickel with some strange results. I tried chromium too, but that really only gave what I think to be just some chromium 3 hydroxide. That's just about all I have for perthiocyanic acid for today. I really hope you enjoyed this video. And I am sorry for not getting a video out sooner. Between work and finding a car I've been wanting for a long time, I haven't had much time for anything. As always, you can like if you want to, subscribe if you want to, and thanks for watching. I will see you guys in the next video.